Okay, let's give you guys some more practice. So if you punch this into your graphical calculator, you will get this graph. Let's just zoom into this bit here. So zooming into that bit will give us this. So we are interested in this region here. So if you look at this here, to try and understand this, you should plot your graph of r versus theta. So here you've got one block multiplying with another block. So this block here would do this. Would be your sine graph. And then this thing here will be like your y equals x. So it would be like this diagonal line here, y equals x. So you've got one block multiplying another block. So when at this point here, this block here will be one times whatever, it will take you to whatever here. So this point moves up to here. This bit here, this block at this point here, sine theta will be 1. So 1 times whatever, it will then take you up to here. This point here will be, well, this point here will be at this point here, sine theta, this block here will be 1 times whatever, it will take you to here. And then if you look at this point here, at that point, this block here will be -1. Well, -1 times this thing here, it will be negative, whatever that thing, it will be the negative version. So this point here will move down to here. At this point here, this block here will be -1. -1 times whatever, it will take you down here. And then if you look at this point here, sine at that point will be 0, or 0 times whatever this point here, it will be 0. So at this point here, where sine theta is 0, 0 times whatever, it will be 0. So this point here will remain the same. This point here, because it's 0, it will remain the same. So as a result, the combination of the two will look something like this. It will look something like this, because this point here moves up here, this point moves up here, this point moves down here, and overall your graph will look like this. So looking at this, hang on. So looking at this, when you've got one block multiplying another block, so you've got your sine graph looking like this, and you've got your y equals x, inner y equals x looking like this. As a result, your graph, your r theta graph, will look like this. So you can see the radius is increasing as theta is increasing. So when theta is 0, so you got your sine graph looking like this. So and then you've got this block here looking like this. At theta equals 0. At theta equals 0, you can see that sine theta will be 0, and then you times the radius. That will, well, 0 times 0, it will be 0. So when theta is 0, the starting point will be here, and then by the time it gets to half pi, when theta gets to half pi, this thing here will be 1, and then 1 times, well, this thing here will be half pi. Sorry, yeah, half pi. And then 1 times half pi, it will be half pi. So by the time the angle gets to pi over 2, the radius will be half pi. So this will be half pi. So it's actually doing this. And then by the time it gets to pi, then this block here, sine of pi, will be 0, and then you times pi. 0 times pi, it will be 0. So by the time the angle gets to pi, the radius will be 0. So it's back to here. So what it's doing is that it starts here. By the time it gets to pi over 2, it will get to here. By the time it gets to pi, it will get to here. So the question is, work out this area here. So what it's doing is theta is increasing each step of the way. So you're summing up all the sectors here. Sum this up, sum this up, sum this up, and so on. So you're summing up everything. So the question here is, find out the area of this loop here. Okay. So press pause and have a go, and I will tell you the answer in the next video. Okay.